Hello, everyone, and welcome to another episode of the Data Standard Audio Experience. I'm your host, Catherine Tao, and today we have Prasanna Madabushi, the Director of Software Engineering at Inseego Corp. And today we're going to be speaking about risk assessments and data engineering. So, welcome to the show, Prasanna. I'm so excited to speak with you and learn more about your journey and just more about your background. So, welcome to the show.
Thanks, Catherine. Thanks for having me on the show.
Definitely. Can you just introduce yourself? Tell us more about what you do.
Definitely. Again, thanks for inviting me. Hello, everybody. I am Prasanna Madabushi. I work as a director of software engineering in cloud and data at Inseego. It's a 5G and IoT wireless solutions company headquartered in San Diego.
Perfect. Yeah. And so data, we know that data is a huge emerging field. Everyone is trying to get into the data industry. Companies are trying to implement data, use AI within their companies to optimize revenue, their company goals, all that good stuff. And so there's a lot of risks that come with this as well and concerns. So, what are some major risks and concerns that you have seen that you kind of think about before actually starting a project?
That's an excellent question. So, data has been around forever. What is new in the last decade or so is the explosion of data, the volume of data, and then the expectation of the customers. They want to see real time analysis of the data. So, typically, when I get started on a data project, I like to find out, hey, what business problem are we solving? And are we looking at new opportunities to explore? And typically, the data projects I worked in fall into two broad categories. One is you're looking at the data to understand and answer business questions. This is looking at the past data to answer questions like, hey, what is our best selling product? And then the other bucket and category, which is more tied to AI ML, is looking at data to predict the future. And so it's important to understand, hey, which bucket does the data project fall into? Is the expectation, going to change from more data analysis to more predictive modeling? And then all of that, will inform how we go about the project. Where is the data sourced from? That is a big thing to understand when you're starting a data project. If the data is something you have internally, then you have a lot more controls over how you process and manage the data. If the data is coming from external third party sources, then there's a lot more data governance, data contracts, compliance that needs to come into play. So that is very important to understand. And then what kind of data? Some data is very structured, and then there is a path for it. And in my world of IoT, which I've been working for more than a decade, the devices, the data that the devices sends is not structured. It's unstructured data. And that brings a whole slew of challenges that you have to overcome. How do you process, differing unstructured data from these devices, and how do you store them, analyze them, and all that? And then from a business side, it's important to ask the question of, any analysis that you need to provide. Are you expecting real time analysis or near real time? And this is important to clarify because, the expectations could vary. In some cases, they could tolerate, data latency of 5 minutes or greater. But other cases, they are expecting you to provide very close to real-time analysis. And all of that dictates, what technology choices and things like that. In terms of risks, you have to do a risk analysis. And typically, there's two things you have to consider. For most companies, just a brainstorming session is sufficient. For data projects, you just get together and say, hey, what are the risks? And what is the probability of this risk happening? And then if it happens, if it does occur, let's say, one of the risks is unauthorized access. You're a healthcare company and you collecting medical records. A risk could be somebody could hack that data. So, what is the probability of that happening? Maybe the probability is very low because of all the controls you have in place, but the impact is very high. If somebody gets hold of the data and it's leaked, the impact is very high. So you have to do at least some rudimentary risk analysis, understand your risk, and for each risk, identify the probability of the risk, and then what is the impact. And once you have that, then you're able to move forward with your decisions. And then in terms of concern, most businesses, the big concern is cost. When the volume of data is in terabytes, the cost for storing them and processing them and analyzing them is significant. So instead of it being an afterthought, it's good to at least get a ballpark estimate at the early stages of the project. Once you have figured out things, once you have a technical architecture in place, it's good to understand the cost for the project, because you don't want to be 6 months into a data project and then you give the business a sticker shock on how much it's going to cost to store this data. So those are at a high level some of the things I think about when I'm starting a new data project.
Yeah, great insight there. I think, especially at the university level, students don't think about the risks that kind of come with these projects that they might be building. So, great insight with everything that you just mentioned. And I know that you touched on a bit about the data aspect of it as well. I wanted to ask you, how do you kind of ensure that the data being collected is quality data? Everything that's being collected is just quality. How do you look for it? How do you clean it? What are your thoughts on this?
This is an excellent question. There is a very old saying in the software industry: garbage in, garbage out. If the data that you are collecting is dirty data, then any analysis and any predictions you're doing is not going to be accurate. So data quality should not be an afterthought. This should be one key consideration from the beginning. When you're collecting data, it's important to understand the data. So most data engineers may not be expert in the field. You typically you work in multiple fields. You might be working in finance, and you might then work in healthcare, and so you may not be the expert in the data that is being collected. So it's important to ask those questions, important to understand what does a typical data look like. What kind of data types, what are the data ranges, and early in the process, provide the data that you are collecting and offer it to subject matter experts. There are typically data scientists at large organizations who are subject matter experts. They can look at the data and they can provide analysis and tell us if the data quality is good or not. And in most data projects, there are what is called as a phased approach to data. We start with bronze data, and this would be your raw data that's ingested. And at this point, you haven't done anything with the data, you're just ingesting the data as is. It's good to collect the source data like this, because you need to understand what the source data looks like. And then silver data is typically the data that's transformed. It's cleaned, it's refined. These are data that your internal data analyst, data scientists can actually start looking at and doing analysis. And then gold data is what you show to external customers. So this is where you have stringent quality controls, and you would not show the data to external customers. Still, typically you get to this gold standard data. And this process, if you think about it, think of this like almost like a water purification system. The data that when you open your tap in the house, and the data water that you get is the golden data equivalent. It's gone through a purification process. The data that is in the reservoir coming from all the streams is a dirty data. It needs to go through several purification steps. So definitely keep data quality as primary consideration, and work with subject matter experts who understand the data from early on, so you get a good sense of what the quality of the data is.
Yeah, definitely. And I like that you also brought in that saying that I hear so much that so many people on the podcast have mentioned, it's garbage in, garbage out. Definitely an important saying that that is just it's true because garbage data will get you garbage results. So super important to make sure that it's quality data and that you're feeding it into your AI and your projects, that and it'll work efficiently to what your end goal is for the overall business goal. So great insight there. And I wanted to hear more about on the data engineering side. What are some common expectations of a data engineer?
That's a really good question. The answer might vary depending on the size of the company. So, in data itself, as a career, there are roughly, again, several different categories. I'm just going to focus on three here. There's a data engineer, there's a data analyst, and there's a data scientist. And in small companies, some of these roles could be done by the same person. In large companies, they could be very defined, structured, jobs for each of these roles. And your question, was about data engineers. So I'm going to focus on that. And the data engineer in most organizations typically is the one building the pipeline to retrieve data from the many sources, load them into what is typically called a data lake. And so they're working on optimizing the data flow, how to extract the data, how to transform the data, how to load the data. So they need to be technical. They need to understand, with today's environment of tremendous volume of data, they need to understand a lot of streaming technologies, because that is how a lot of data gets into a company. And they need to be familiar with the sources of data, SQL, NoSQL data systems, because that's where you're going to extract the data from. And then you need to be familiar with building the pipelines, orchestrating, this. And there are a few technologies. If you're interested, Catherine, I can talk about a couple of technologies. And then you need to at least have some understanding. Uh, Early on, you may not need to be an expert in this, but you need to understand data governance, data privacy, and data security. In terms of tool sets, again, there's several different tool sets. Two good ones is using Python for the data pipelines. These engineers build pipelines using, Apache, Spark, and Python. That is a good technical area to focus on. There are engineers who build pipelines using Scala. There is Flink, Scala. These are, again, both very good streaming technologies. Of course, familiarity with, just plain old SQL always comes in handy. If you're interested in more AI ML stuff, that one takes a slightly different form. But I'll stick here with, how most companies are going to find a data engineer, someone architecting the data pipelines.
Yeah, definitely. And it's a new immersion field also. So a lot of universities are teaching more of the aspects of data engineering, how to collect the data, how to make sure it's clean, how to clean the data, all that good stuff. So great that you're able to share your experiences with this also. And I wanted to talk more about the privacy and security aspect of data now. So how do companies and how does your team ensure that privacy and security are within the data and that everything will be secure and nothing will be leaked or anything like that?
I mentioned risk analysis earlier on for your question about what concerns and risks you have on data projects. So think of it this way: if you're a museum, you know what your crown jewels are. You know what your famous paintings are. If the Mona Lisa is your most famous painting, you would do a risk analysis and say, hey, what will happen if somebody steals the painting. So that is same with data. You need to understand what your crown jewels are, because typically companies collect a lot of data. Not everything falls into the same bucket in terms of what you need to safeguard. This is where, like I said, a simple brainstorming session is sufficient to understand your data, classify the data, understand, hey, if this data is, and again, the risks are in many forms. One is somebody could hack in and they could get the data. Somebody could corrupt the data, and somebody could make it such that you're not able to access your systems. So it's multiple phones. You need to understand, hey, what will happen if somebody leaks this data? And again, if you're a health care provider and you're collecting patient medical records, leaking that has governmental compliance and governance ramifications. If you're financial company collecting people's credit card information, social security number, again, those are your crown jewels. You don't want that leaked. You have to protect this. You have several layers of protection. You safeguard who can see the data. The data is encrypted many times, and you have all that in place. But you may have other data that it's low impact. If somebody finds out, maybe it's not such a big deal. So typically what I do in terms of data access in our production environment, I start with something called zero trust, meaning nobody gets access to the production data by default. So if you need access, that is something that you have to request, and then we would grant it. And this principle of zero trust system is essential in a production environment to make sure you control who has access to the data, because in the olden days, a lot of, especially when things were on premise, a lot of people had access to the data. They were running in a server room within your company. But now in the cloud, of course, the risk is anybody can get into it if it's not protected properly. So that's where the zero trust comes in. Nobody has access, and if you need access, there needs to be a reason for it, and you're given that. Yeah, again, like I said, think of your job as like somebody in charge of the museum security. You need to understand which paintings are the most important that you need to protect. Same with the data that you collect. You need to understand, hey, what data is very crucial to protect, and focus on those first.
Yeah, great museum analogy too. I really like thinking about it that way in terms of data and just wanting to protect that, the museum painting or the data that you have. So great insight there. I love that. Yeah, and I just want to say now, thank you so much, Prasanna, for joining us today. So great to speak with you and learn more about your industry and your experiences. And so we at the Data Standard, we're trying to build a community of data enthusiasts and data thought leaders so that everybody has a place where they can all network and collaborate. So what is something that we can do for you?
First of all, what you're doing is fantastic. That is a much needed initiative. Like you said, a lot of this is cutting edge technology and field. What can be done is bringing people together who are in the industry, and having discussions would be definitely beneficial for the community and for folks working in the industry, because then you get an exchange of thoughts and ideas and discussion on what is working for us and what is not, and that experience as well.
Absolutely. And where can everybody find you online to connect with you?
I am on LinkedIn. That's the best place to find me. I think my LinkedIn ID or name is P Madabushi.
Perfect. And to our audience, for more information on the Data Standard, you can find us at www.datastandard.io, as well as our LinkedIn and YouTube channel. And this episode is sponsored by Pandio. They're innovating the tech space with their Apache Pulsar messaging system, kind of helping companies be more data-driven and AI-driven. So check out their product at pandio.com. And thank you so much, Prasanna, for joining us. So great to speak with you. And we definitely hope to have you as a guest in the future again soon.
Thanks a lot, Catherine. Thanks for inviting me.